Hello students, and welcome to our video lecture on units and dimensional analysis and how to incorporate significant figures in that. So let's first talk about what a conversion factor is, because you probably don't know what dimensional analysis is, and we can't really do it without talking about conversion factors. So when we look at a conversion factor, it is saying two things are equivalent to each other. So like right here, we see that 2.54 centimeters is equal to 1 inch. And when we start talking about conversion factors, we can take that equivalency of 2.54 centimeters in an inch, and we can write it two different ways. One way to write that would be to write 2.54 centimeters on the top and the 1 inch on the bottom, where this line that I've drawn between them is the same as an equal sign. And we can also flip this and have our 1 inch on the top and our 2.54 centimeters on the bottom. So what we'll do at the bottom of this page, after we talk some more about conversion factors, is utilize this specific conversion factor to decide, when do I know I need to use this one versus when do I use this one? So let's talk about conversion factors in more detail. Some conversion factors are measured quantities. For example, we are measuring the number of meters that 1 second is equivalent to when we're looking at the speed of light in meters per second. So what you'll find when we take the speed of light and report it, we often do not write 2.9979 so on in 1 second. We round it to something that's more realistic. So there's definitely significant figures associated with this. And as I'm looking at this, I think I have a typo. It should be times 10 to the 8th there as well. So the other thing that's measured would be, for example, Avogadro's number. If you've taken chemistry before, you know what Avogadro's number is. You know that it's the number of atoms or particles or molecules that make up 1 mole of something. So we can definitely have more digits past the 6.022. We just happen to round it to make it more manageable. So these conversion factors, they are measurements, and because they're measurements, there's an uncertainty to them. And due to the fact that there's an uncertainty, we should be utilizing those as we are reporting significant figures through the end of our calculations. There are other conversion factors that do not have uncertainty. They are definitions. Some people call them exact. Some people say that they have infinite significant figures. So for example, if we are converting inside the metric system, so if we're going from one metric unit to another metric unit, so saying that there's 100 centimeters in a meter, that's the definition of centimeters in a meter. So here, this has infinite sig figs or no sig figs, whichever you want to consider. So you're not concerned with significant figures of these conversion factors changing the significant figures in your final answer. Other things that would be considered exact would be the number of seconds in a minute, and that would be something that's exact because that's, again, our definition of the number of seconds in a minute. It gets a little tricky when we start talking about something like days in a year, because, then we have something like the leap year and so on. And then even sometimes a little tricky when we talk about money, because there's some examples where, when you buy gas, it's not $4.20 a gallon. There's like a little taxation in there as well, where you're not dealing with a whole cent. So that's why there's this stipulation down here, conversions involving money, as long as we're dealing with whole cents, would be something that's exact. And here at the bottom, I have some more gray areas, and you don't have to be too concerned about the gray areas. as I am not someone to be concerned about asking you to remember all the crazy little discrepancies throughout chemistry. Let's talk about what we want to be able to do with these conversion factors. So with the conversion factors, we want to be able to solve a problem like this one. Convert 50 inches to centimeters. So let's recap. At the beginning of this video, we saw something that said that there were 2.54 centimeters is equal to 1 inch. And we said we could take that and write it one of two ways. We can take the 2.54 centimeters and put it on the top with the 1 inch on the bottom, or we can flip that around, put the 1 inch on the top and put the 2.54 centimeters on the bottom. These are all ways to write a conversion factor. Now we just need to figure out which way to write it so that it works for us. So then, separating that idea from our work over here, let's take our 50 inches and start converting it. Now, a lot of times what ends up happening is that students who are quite good with math in their head really get frustrated in this section because they know what to do, and either they don't know how to turn it into dimensional analysis on the paper, or they just don't want to. So try to remember that the reason we're learning dimensional analysis right now is because when we get to chapter 3 and we have to do dimensional analysis in moles, you need to have the process down pat first. So we're going to learn the process now in something that's tangible, and then we'll use it more later on. So I've got my 50 inches. This is what I'm given. And then I'm going to multiply that 50 inches by a conversion factor. So what I'm putting here is going to cancel the inches and leave me in my desired unit of centimeters. So then I have to stop and decide, if I'm converting 50 inches to centimeters, which one of these conversion factors do I put in the green box? And so the goal is to cancel out your units. When we want to cancel out our units, what that means is whatever unit is here on top needs to be the unit that's on the bottom in the following term. So the 1 inch needs to be on the bottom, which forces the 2.54 centimeters to be on the top. So your inches then cancel. You are left with units of centimeters, which is what you desire. So then you put it in your calculator. You take 50, you multiply it by 2.54, you get 127. And so now what you might be noticing is the reason why you previously watched a short video on how to use significant figures during things like addition and subtraction. We'll talk more about the multiplication and division rules in class, but very simply, you choose the term that has the least amount of significant figures. So here we have 3 sig figs. And over here, when you have a conversion factor like the one that's boxed in green, you don't consider the 1 in your significant figures because that's like your constant, right? So the 2.54 would be the 3 sig figs that you're considering. So if you have 3 significant figures and you multiply that by something that has 3 significant figures, your final answer should also have 3 significant figures, which is what we had here that our calculator already gave us. So our brain doesn't have to do any work. We just box our final answer and we're done. Let's do one more practice that's a little bit more difficult, and then we'll save the rest for class. So in this next one, it's asking you how many nanograms are in so many kilograms. So one of the things that people struggle with is when they're doing units analysis, they don't have certain things memorized. Remember when we talked about the Bloom's taxonomy, the learning pyramid, some things you just have to have memorized before you can start to apply them. So the things that you have to have memorized are the metric to metric conversions. So things like that they're in 1,000 grams is 1 kilogram. So having that memorized. Knowing that there are in 1 gram 10 to the 9th nanograms. Those are things you want to have memorized. Whereas like up here, the metric to English ones, I don't expect you to memorize those. We can create a more comprehensive list in class of the ones we're going to memorize. So the stuff here on the left is the stuff that we have hypothetically memorized in our head. And so now let's start to use those components. A lot of times students struggle because they are worried about going directly from kilograms to nanograms. But you don't have to go directly from one unit to another. If you are at kilograms and you know how to link kilograms to grams, then what you can do is go from kilograms to grams and then link to nanograms. So that's your little pathway that you're taking. So now let's take our equivalency here and turn it into a conversion factor. So we have kilograms on the top term here. That means we need to have kilograms on the bottom term of the bottom of the next term. Notice how there is a number 1 next to the kilogram in my equivalency, so I'm going to put a 1 here. Then that is equivalent to 1,000 grams. And now my kilograms have canceled. Now that my kilograms have canceled, I've gotten from kilograms to grams. Now we're going to go to nanograms. So I look over here at my next equivalency. I know that my grams needs to be on the bottom, again, because my grams was on the top here. My grams has to be on the bottom here. And if I look at my equivalency, there's a numerical value of 1 in front of my grams. And I know that 1 gram contains 10 to the positive 9th, not negative 9th, nanograms. We can talk about that more in class. So we go through this process, and you can either plug it into your calculator or you can use your mental math and remember that when you multiply exponents, you're really adding them. And what you might do is practice putting these things in your calculator, because a lot of times what ends up occurring is folks use a different calculator for practice that they do on the exam, and then they really struggle. So if I did this correctly, this is, if I'm going to do my mental math, 10 to the third. So 10 to the third times 10 to the 9th is 10 to the 12th. So I should end up with 0.527 nanograms. Okay. So if we stop and we talk about significant figures, here, 3 sig figs to start. These metric to metric have infinite significant figures. So we have 3 sig figs at the end. Because, as we'll discuss more in class, the multiplication and division rule for significant figures is the term with the least amount of significant figures limits how many you're allowed to have in your answer. If you'd like to try this bottom one before class, please feel free, and we will pick up in class with quite a few more units analysis problems. So thanks for joining me, and thank you for your attention. We'll see you soon. Katoni signing out.